Today we're going to start talking about factoring. We're going to do this in several little parts because there's different parts of factoring. I think each one of them needs their own little video. So today the factoring is going to be mostly about finding the GCF, which is the greatest common factor, and the difference of squares and sum and difference of cubes, all of which are very important and need to be emphasized a lot. So let's get going. All right, so factors are numbers that when you multiply them together, they give you a number. For example, the factors of 6 are 1 and 6 and 2 and 3. 1 times 6 is 6, 2 times 3 is 6. So, what are the factors of 27? Well, we know we have 1 times, let's make that better color. 1 times 27, okay? 3 times 9. Okay, those are factors of 27. So what you're going to be looking for when you do this, when you start factoring, you always want to find your GCF and do that first. No matter what kind of situation you've got, always GCF first. Because you might find there's some other pattern after you do that. You're going to rewrite these quadratics into two or more equal factors when you factor quadratics. So let's get started on these. Greatest common factor, of course, was GCF. And that's a number, a variable, or a combination of a number and variable that's common to all the terms. Okay, so it could be a number, a variable, or a number and variable. The GCF will be divided out of the original expression. So, example A says, what's the GCF of 18 and 27? You want to find the biggest number that can come out of both 18 and 27. All right, so let's look at this. I can take a 9 out of 18. Can I take a 9 out of 27? Yes, if I can take a 9 out of that, and this, that's probably the highest one, then that is going to be my GCF. So let's check this. Okay, one of the ways you can check if you need to in our calculator is use math, scroll over to num, and choose number 9. And it's going to say GCD and have a parenthesis, okay? All right, and then what you want to type in, you can only type two numbers at a time, no letters. If you type in 18 and then put a comma, which is right above your 7, and then put your other number, which is 27, and then close it off. And it'll tell you what the GCF is. So let's do it. Math num 9, and then 18, comma, 27 in our calculator, and we get 9. 9 is the GCF. So you can do it this way if you have trouble with your multiplication tables, or you may be able to see it. Now, this will not give us a GCF with letters, so we'll always have to look at those separately. We will only do numbers and only two at a time. All right, example B, 14 and 42. Pull up my 83, show you the calculator itself. All right, so if I wanted to do the math num thing, I'm going to hit math, go over to num, and then 9, which is GCD. Type in 14, comma, and then 42. Close it off, hit enter, and you get 14. So 14 is our greatest common factor between 14 and 42. All right, the next one says 27xy plus 3y. Now, the smallest number has got to be the greatest common factor because you cannot make 27 into 3, but you can make 3 will go into 27. So 3 is definitely going to be the number part of the GCD. What else is in common between these two terms? That's right, we have a y in common, so we must take a y out. And then you're going to divide. What is 27xy divided by 3y? 27 divided by 3 is 9. X divided by nothing will just be x. Y divided by y is 1. So that's all we write is 9x. There's no point in putting a 1. You can just just make 9x, plus 3y, take away and divided by 3y is 1. You must put a 1, you just can't put 0, because that would not be true. 3y divided by 3y is 1. Okay? That's why we have to put a 1, and it's not 0. So this one is now factored. All right, and then this one, it says 15x cubed y5 plus 30x y squared. All right, so between 15 and 30, you can probably easily see 15 must come out. You can always use your calculator if you need to. Then you want to look at your variables. The lowest number degree variable, if it's in common, that's what you take out. I have an x3 and an x to the 1 power. I can take out only 1 because that's all this one has to offer. y5 and y2, the smallest one is the 2, that's all I can take out because that's all it has to offer. So when you take out 15xy squared, you divide it from this term. 15 divided by 15 is 1. You can put a 1 or you can leave it alone. x3, take away x1, leaves x squared. y5, take away y2, is y3. Okay? Plus 30 divided by 15 is 2. x1 divided by x1 is 1. y2 divided by y2 is 1. So the answer is just 2. So this one is now factored. It's now 15xy squared times x squared y cubed plus 2. Okay? All right, common patterns. I cannot emphasize this enough. You must know these. These are all over every test you're going to take in here because they're patterns you need to be looking for. These are shortcuts that will make your life easier. You must know these. Okay? Perfect squares. Perfect squares are numbers times itself. You must know these. So if you don't know these, now's a good time to learn these. Examples. 1 squared is 1. 2 squared is 4. 3 squared is 9, and so on. So if you need to figure them out, just write them out and then work them out. But you should recognize these numbers now, okay? These are used a lot. Also, you're going to have squares of letters, a squared, y4, x6. Anything that's an even power, you can split them up when you're factoring evenly, okay? So anything that's even, you can split those up also. And we have this term difference of squares. This is a certain pattern that only happens when we're talking about a difference. What does difference mean? Difference means subtraction. Okay? So it only happens when you're subtracting two perfect squares. Addition will not work when we're talking about squares. All right, so the first example, we've got a squared minus b squared. That will factor into this pattern. A minus b times a plus b, or vice versa. These can be switched. Does not matter because multiplication is commutative. Okay, so it could be a plus b first, and then a minus b. Does not matter. But you'll notice that you have an a and a b in both. Just one is negative and one is positive. That's the pattern that you're going to be looking for when you have a difference of squares. Same exact factors, one positive, one negative, and you can go and try to distribute that and see what happens. Let's do that. A minus b, a plus b. Okay, when you distribute, you get a squared, ab, negative ab, and then you're going to get a negative b squared. Well, what happens right here is those cancel. Because those cancel, you're left with a squared plus minus b squared. That's why it cancels. That is the only reason why it cancels, because we have one of them to be positive. Because you have one positive and one negative, they completely cancel. Okay? Completely cancel. Now, we worked with these before. when we were doing other problems, but these are going to cancel. When we were doing the compositions and we were plugging in, we worked with this kind of situation. This is why this cancels. Okay? Note, with squares, this only works if it's a difference. Addition will make non-real answers. And right now, we don't know what those are, but we will be learning this year how to find those answers too. So, let's practice a couple. All right, so I have 25x squared minus 49. First, you want to see if there's a GCF. There's no GCF. Then you want to see is 25 a perfect square. Yes, 25 is a perfect square. X squared, that's going to be easy to split up. And then 49, that's a perfect square. And do we have a difference? Yes, we do. So we can go ahead and split these up to make 5. It's 25, the square root of 25 is 5 and 5. And then split up your x's. And then square root of 49 is 7. And one's going to be positive and one's going to be negative. And that is how easy factoring difference of squares is. Number 2 says 16x squared minus 81. Is 16 a perfect square? Yes, it is. How about 81? Yes, it is. Do we have a difference? Yes, we do. And x squared makes this a perfect square, and difference of perfect squares can be split up really, really easy. Square root of 16 is 4. Split up your x's. Square root of 81 is 9. And then we have one positive and one negative. Okay? And if you want to check these, you can pull them back out and see if they work. But you'll notice they have the same exact terms, one positive and negative. All right, the next one, 4x squared minus 9y squared. 4 is a perfect square. 9 is a perfect square. We can split x squared and y squared up, and we have a difference. This one is also difference of squares. Split the 4. Square root of 4 is 2. Square root of 9 is 3. Split up your x's. And split up your y's. Okay, one positive, one negative. This one works. Check it by pulling. Okay? Alright, next thing. Sometimes you must GCF first before you will see that difference of squares. Remember, you should always GCF first. So let's look at example 4. It says 5x squared minus 125x squared. Is there anything that's in common with both of these? 5 is in common, so let's take out a 5. We also have an x squared and an x, so I can take an x out. When I do that, I'm left with just an x, okay? 5x squared minus, I think that should have been 25, but that's okay. Minus, and then 125 divided by 5. It's going to be 25. And then m squared. I think this one probably was a typo, but we'll go with it right now. So it's going to be 25m squared. We took an x out. Yeah. Yeah, this one's just simply 5x times the quantity of x minus 25m squared. Because we had an x in common with both, and 25 and m squared would break down, but this does not. It would have to have a square right there when it breaks down. This one is gone. All right, number 5. We have a 7 and 4 and 3 and a negative 28 and squared in. 7's in common. We have m squared that can go out and an m. Once we take that out, we're going to be left with m squared, n squared, minus 4. So we took out n squared, and that's all we got. Alright. Okay? Alright, so inside here is a perfect square. And if that's the case, you just keep bringing your GCF down. It doesn't go away. It's very important to this problem. And then split the rest up. So I'm going to have m minus 2, and then I'm going to have m plus 2. Okay, that is my final answer for this problem. Okay? All right. Sum and difference of cubes. We have a couple of acronyms to help with these, and these are extremely easy to do. You just have to remember your acronym. All right. Cubes, you're going to have cubes as your exponents, and these are the patterns that you need to know. Okay? But let me show you how to do it. When you're doing these, this is a difference of cubes, and this would be the sum of cubes. Okay? It's split up in this certain pattern. The way you remember that is to think about SOAP, S-O-A-P, and K-Spring Middle School. Those are the easy ways to do it. SOAP will get your signs right, and K-Spring Middle School will tell you what to do with the numbers or letters. All right, so to find the sum or difference, you take the cube root of the first term. So that's why we take a cubed and make it a. The cube root of a cubed is a. Then you take the cube root of the second term, so b cubed will split up to just b. And then you multiply the two together, a times b. After you take the square, I forgot to show you that. Let's go back. Take the cube root of a cubed, that's a. Cube root of b, that's b. Then you take square of the first term, which is a squared. Multiply the first two together, a and b, that gives you the ab part. And then take the square of b. It's easier to just show you the example as we do it, and then talk about the signs, okay? Signs are same sign, opposite sign, always positive. And this will make sense when we do a couple problems. For instance, 8 is a perfect cube, and you need to know the cubes as well as you need to know the squares. 2 cubes, 3 cubes, 4 cubes, 5 cubes. You need to know those. All right, so the cube root of 8 is 2. Okay? This should have been it to the third power, sorry. And then the cube root of a cubed is a. And then we're going to take the cube root of 27, which is 3. Now, our thing says SOAP for our sign. Same, opposite, always positive. So the same sign of this would be a negative. Okay, then go ahead and put your parentheses. Same sign, opposite of that sign, and always positive. So this is how you set up your signs. Now we're done with the signs. You just put your stuff in with your K-Spring Middle School part. So what is 2a squared? That's going to be 4a squared. Right? Multiply these two together. 3 times 2a makes a 6a. And then square the back end. 3 squared is 9. So this one now is factored. Just like that. All right, so what is, well, number 2, what is the cube of 64? That would be cube root of 64, which is 4. Cube root of x3 is x. Okay? Same sign. What is the cube root of 125? 5. Cube root of y3. Y. Okay? And then you're going to do same sign, opposite, always positive. Then you start doing the rest of your problem with the K-Spring Middle School part. What's 4x squared? Well, that's going to be 16x squared. All right, multiply these two together. That's going to be 20xy. And then square the back end, which is going to be 25y squared. All right? So another one. Again, if you can possibly, GCF, you need to try that first. I'm looking at this one. I've got a 4th root and an a. I see a 24 and a 3. So I know 3 comes out, and so does an a. That leaves me with 8a cubed minus 3a divided by 3a is 1. Now notice, this right here may not seem like it is, but this is a difference of cubes. Okay, 1 is a perfect square, and it's also a perfect cube. It's perfect all the way around. So when you do this one, this 3a GCF has to go along with it, so you don't lose it. So we're going to do what we did up above, and we're going to take the cube root of 8, which is 2. Cube root of a cubed is a. This thing is not writing right today. Okay? Then we're going to take and do the same sign, opposite and always positive. What is then 1, the cube root of is 1. Real simple. Take the first term and square it, so that's going to be 4a squared. Not 4 degrees calibrated, I can tell. And then multiply these two together, which makes negative 2a. Excuse me, positive 2a, because the sign has to be opposite. And then square the back end, which is going to be 1. So that one is done. Right? Number 4 says 5x cubed y negative 40y cubed. Excuse me, y to the 4th power. So I know I can take a 5 out, and I can take a y out. When I do, I'm left with x cubed minus 8y cubed. Notice the cubes, that means you look and see if it's a difference or a sum of cubes, and it is. So again, bring your GCF down, can't go away, you have to have that. Alright, cube root of x cubed is x, same sign. Alright, cube root of 8 is 2. Cube root of y cubed is y. Alright, and then you're going to have, if this is negative, you say opposite sign, always positive. Square the first term, square the last term. And then multiply these two together, so it's 2xy. Okay? Sorry, my pen is acting like crazy. Alright, so what can I do with number 5? GCF, I know 3 will come out, and an n. Leaves me with 2n plus 3. That's as far as this one can go, because there's nothing else going on. Alright, 7x squared minus 21. Take a 7 out. I'm left with x squared minus 3. This is not perfect. This is as far as this one will go. Next one says x squared plus 9. Well, that's perfect square. That's perfect square, but this is addition. This is simplified for now. And we'll be figuring these out later. This is not a difference of squares. This is addition or sum of squares, and you cannot do that. That makes non-real numbers, which we will discuss soon enough. This one, that's a perfect square. That's perfect square. That's perfect square. And so with that one, we have a difference. So this breaks up 7x minus 10y, 7x plus. Again, you can check all these by forwarding back or distributing back. Okay? And I believe that's all of them for this time. We will finish up factoring in a couple more sections. Come see me if you have any questions. See you in school.